All right, so looking at partial fractions again. This is the third video about partial fractions. This one's when the denominator is what's called irreducible. It means basically it can't be factorized. You would have come across irreducible quadratics in your study of quadratics. Basically, it means that the denominator has a discriminant that's less than zero. So we can't factorize it. So for every irreducible quadratic factor in the denominator that has this form, there'll be a partial fraction of the form ax plus b all over ax squared plus bx plus c. So what we need to do is, we need to resolve this is a good example of um, a fraction that can be decomposed into partial fractions. And this part here is irreducible. The discriminant of this is less than zero. Remember, the discriminant is b squared minus 4ac. So if you calculate for that for this part, you will get that that's negative. So we need to use, we need to use this approach. So let's see what that looks like. So as we said before from previous videos, if you've got a linear factor there, that's going to give you a partial fraction of this form a over x plus 1 in this case. And what this is saying is, if you've got an irreducible factor in the denominator, you have something of this form, ax plus b all over, excuse me, all over ax squared plus bx plus c. So you get bx plus c all over x squared plus x plus 1, which is this part here. And our job now is to find A, B, and C. So let's jump into it. What we're going to do, like we've done in previous videos, is going to multiply both sides by this denominator, by this thing here. So you get A, you multiply this denominator by this fraction here. The x plus 1s will cancel out, and you'll be left with A multiplied by x squared plus x plus 1. And you'll get bx plus c multiplied by x plus 1, because this thing will cancel with this thing. All right, so what we're going to do from here is we're going to make life easy for ourselves. Let's look at the moment that if we've got x plus 1 here, if we make x negative 1, then this whole term here goes to 0. Okay, so remember we sub in x as negative 1. So I'm going to get on the left-hand side, we'll get 3 times negative 1 plus 1, which is negative 2. Then a multiplied by all this. I encourage you to get out a pen and paper, but that's hopefully pretty straightforward. You just sub in negative 1, and straight away it'll just give you that a is negative 2. So straight away we know that a is negative 2. Okay, the next thing we're going to do is we're going to sub in a being negative 2. So now I've just got this line again, but a is negative 2 now. And then from there, what we're going to do is we're actually going to have to expand things now. So I'm going to expand that negative 2 in. So we get negative 2x squared minus 2x minus 2. All right, and we're going to expand these brackets. So it becomes bx squared plus bx plus cx plus c. Okay, we keep going from there. We can hopefully come to this conclusion, which is not too, hopefully too scary. If we were to look at the constant terms, we know on the left-hand side that the constant term is 1. On the right-hand side, the constant terms are minus 2 and c. So minus 2 plus c must equal 1. So therefore, c equals 3. All right, so we've got our two letters already. We've got A and C. Let's find B now. So what we're going to have to do is we're just going to come back to this line here again. But now we know what C is. We know C is 3. So if there was a C, we just put a 3 now. Okay, what I've done here is I've shown a bunch of steps, but I'm hoping you can hopefully work out how to find C. I think all I did to get from this to this is that I've just collected any like terms. So minus 2 plus 3 is plus 1. So that's all I did there. Here, I just put the x squared terms next to each other. So minus 2x squared plus bx squared plus bx. Okay, minus 2x plus 3x is plus x plus 1. What do we do here? All we're saying is, all I literally did was put bx squared first. Everything else is the same. I'm sort of working it out as I did it, as you can tell. So, all right, and then you get to this. And all we're going to do is we're going to take out x squared as a factor here, and we're going to take out x as a factor of these two terms. So on the right-hand side, we get this. And what we're going to say is, okay, we know that the coefficient of x is 3 on the left-hand side. So b must be 2 because, yeah, it has to be 2 because 2 plus 1 is 3, and we're equating coefficients. And that should make sense here that b is 2 because 2 minus 2 is 0. So 0 times x squared is 0. So there is no x squared term on the left-hand side. So that sort of checks out. And then we're obviously left with the plus 1. So after all that, we can say that therefore b is 2. And so finally, we can come to the conclusion. We can say that this fraction, if it's decomposed into partial fractions, is negative 2 over x plus 1 plus 2x plus 3 all over x squared plus x plus 1. All right, just subbing in a, b, and c into this, right? All right, hopefully that made some sense. Try this out. See how you go. Resolve 3x squared plus 2x plus 5 all over x squared plus 2 by x plus 1. Start to think about which one might be the irreducible quadratic. If you find the whole idea of the discriminant challenging, think of an irreducible quadratic as being any quadratic that doesn't have any x-intercepts. X squared plus 2 is not going to have any x-intercepts, is it? It's not going to hit the x-axis at any point. So therefore the discriminant's negative. All right, good luck.